Okay, so let's begin. The main theme of this talk is going to be making Amiga demos without having an Amiga, because that's what we are doing since like 10 years now. And I will talk about how we approach it, and yeah, maybe you can learn something and start doing what we are doing. So let's begin. I will introduce myself. I'm Kiero, currently from Elud. I'm on Demoscene since 17 years now. I was a member of Appendix, Mad Wizards, currently Elud, but participating in other, as a guest coder in other groups as it fits. I was doing graphics since always, and by profession I'm kind of opposite of what I'm doing on Demoscene, because I'm doing backend programming, Java, high-level server stuff. So Demoscene is kind of trying to escape from all this business crap. And yeah, my background is more than 30 demos throughout 17 years now. So yeah. What we are going to be talking about today, Amiga demos is kind of a broad topic, but you can separate it into main two categories, old school demos and new school Amiga demos. Old school demos being Amiga 500, close to the metal, hardware-based effects, chipset, programming. And high-end Amiga demos are kind of not true Amiga demos. They are just generic software rendering effects which you can do on any platform, which I will demonstrate. Our demos are not utilizing almost any Amiga-specific features. We are not banging the hardware. We are not using even modules. We are using streamed music. We are not doing true color graphics. But that's not because that's not because it's the limitation imposed on us, but it's kind of a decision we picked based on the effects you can do. But that's not important. And the presentation is going to be how we make demos and not how Amiga demos are made in general or current Amiga demo scene. So the main things about making a demo is that you want to make Amiga demo, but you don't have Amiga. Amiga is expensive. Hardware is hard to come by, and you don't really want to invest too much money to make one production a year, so you have to somehow deal with it. Second thing is kind of connected to the first one. Prototyping is how you approach to make a demo. You have not much time, and you need to do as much as possible in this short time you have. So it's going to be how you organize your workflow, how you organize your tools to not spend too much time fighting with tools and hardware, but trying to do creative work that you are doing. I will talk also about some optimization, but from a different point, maybe of view, not counting cycles in assembly, but helping the tools to do the work for you, helping the compilers, and yeah, just trying to not do any work and get the results. And if we have some time, I will talk about how we help our graphicians mainly with some tools we have prepared for data conversion, asset management, and stuff like that. But this is just extra. Okay, this is basically what I was talking about in the on the previous slide. So yeah, let's skip. So lots of you might ask the question. We have great emulators like WinUAE, where you can run your code and yeah, it's going to be great and fantastic. But it's not so great if you want to do high-end Amiga demos, because WinUAE is great when emulating Amiga 500. It has cycle-exact CPU emulation, exact chipset emulation. It's awesome. But when you want to do high-end Amiga demos, 060, pure frame buffer, stuff like that, everything breaks. You can't have cycle-exact emulation because WinUAE is running fast as fuck. You have to do some estimations. Basically, emulation is just some visualization tool for you, not really something that you can trust when making a demo. So, how to work around it? Yeah. So, is it really a deal breaker? Do you need Amiga to make Amiga demo? Not really. I didn't have real Amigas since 10 years now, and we released like 10 demos already, so you can do it if you want. And I will just show how you can do it. So the main idea is you need someone to help you with this. You need a friend, someone on a forum. You need someone with physical hardware. Yeah, I will call it a slave, but because that's what it is. I have my personal high-to Fibrizzo, and that's the guy who's going to help you at the beginning of the process and at the end of the process. At the beginning, because he will help you to estimate how your emulation works, and at the end to see how the effects are performing on the real hardware. So if you got the slave, now how do you, now the next step. So you never coded on Amiga. For example, you have some MS-DOS background or in general software rendering background. So you think, I never had Amiga. Do I need knowledge about Amiga hardware? I don't know Amiga assembly. Basically, two main showstoppers, which we'll talk about, but yeah, maybe about some more later. So, okay, let me check my notes because I'm kind of not organized properly. Okay. Like I talked about in one of the first slides, we are not coding to the hardware. Our demos are mainly just utilizing the frame buffer. This is just the same as coding MS-DOS demos or early PC demos in general. So you don't really need knowledge about Amiga. You are just either taking some framework from someone else or just learning the minimum requirements to display graphics. That's really simple, and it's the same on Amiga, it's the same on PC, it's the same on every platform. So if you are not using any chipset-dependent stuff, you just need the frame buffer. About the assembly knowledge, that's a bit harder, because if you want to do something more ambitious, than the simple, I don't know, scrolling graphics, some abstract, simple stuff, you will need to learn at least the minimum of assembly. But Amiga assembly is simple. You can learn it in like half a year, so it's pretty simple. But really, you are not going to be coding in assembly, mostly. Like, with our demos, assembly code is maybe less than 5%. So it's mostly C, C++, C, but mostly C. And assembly is really in the really tight inner loops. I don't think any of my routines is longer than 100 lines. So you just need some basic concepts, some loops, some jumps, basic register organization. That's really not a showstopper as you might think. If you are prepared to overcome that, yeah. So, the ingredients if you are approaching Amiga demo. If you are, for example, alien to Amiga demo coding, you will not start from the beginning because you are going to be demotivated really soon. You are not going to get any effects without spending time. You know, you need to see something on screen. That's what motivates you when you are making a demo. You like watching the stuff that you are making. So you don't want to be spending time on tools. And that's when frameworks come in. Either you find something on the website, there are a few at least available for Amiga, or you find some friendly demo coder who's going to lend it to you. And now is the funny part, maybe for most of you. We are going to be making Amiga demo on a PC. And not only PC under emulation, but on PC in Visual Studio and running as a native Windows application. So if you have no background or knowledge in Windows programming, that's going to be the way for you. And it works really great, which is kind of sad. Okay, so if you are, for example, Windows developer, you know Windows tools, you will pick your compiler of choice as a cross-compiler, for example. You can build everything on Windows and just run WinUAE to test your stuff. But this is not really the optimal approach. Cross-compilers are really poor. GCC for Amiga produces poor code, VBCC produces even worse. And the worst part is the native Amiga compilers produce the best code. So you will need to strike a balance between using some Amiga tools and prototyping on PC. So it's not really that easy, but most of the work we're going to be doing still on Windows. About additional tools, that's also the case. If you have some background in Amiga development, in Amiga programming, it would be easier for you to code them on Amiga and run them kind of as in a demo, on a real thing, for example. But if not, just do it on Windows and it's going to be fine. Debugging is the biggest advantage of running on a real Amiga. Because things that work on Windows, it's running through your abstraction code. It's not native code that's going to be run on a demo. Sometimes you have to, things will break when it works on natively, things will break when you run it on Amiga. So you still need some kind of layer, some knowledge of tools on native hardware. So if you never used an Amiga, you better get used to it, at least to some point. Okay, so I don't know if you can see it, but this is the basic structure. And okay, I will go into split it later, but it's demonstrating how basically our demo looks like. I don't have to explain it because it's going to be separated later. Okay. That's the most basic point, is doing some lookups, trigonometric functions, precalculation. Basically, this is the same part we did on PC and Amiga. This is nothing to talk about. Now, this is probably the most important part in our demo framework. The system variables are variables that are exposed to other people than developer. They are exposed outside of the demo. They are written to external files. They are also reloaded from external files at runtime. They can be tweaked through the UI and other external tools. So this is the main point when it blends between developer and artists when making a demo. They allow you to, tweak things when the demo is running. So you don't have to rerun and rebuild, recompile, and it really optimizes your framework. I will talk about it and show it. I will show the UI and talk about it a bit later. Another part is file system abstraction. You want your demo to be running on PC, as I told. So you need to handle different directory separators, some file containers, things like that. It has to be transparent. It also helps you to reload resources at runtime. Because when Graphician is working on some graphics, he doesn't want to rerun your demo all the time and probably skip to the part. He wants to see the result immediately. So we have the functionality to just look at the file changes, and if the Graphician is saving the file in the editor, it immediately pops up a modified version on the screen. That's really important and it saves time. It also allows you, but this is not what we implemented on Amiga on PC, but we investigated the concept when making Android demo. We experimented with resources through network, because when you are developing for the mobile devices, it's time-consuming to constantly upload them to the device. And we had FTP server connected, and through this abstraction, it was transparent. So even if it was modified on a remote machine, it would be uploaded transparently to mobile device. Okay, this is probably the main part of making modern Amiga demos. So you just have a buffer to fill in every frame. And as you can see, there's nothing Amiga dependent, nothing Amiga specific. You just have the buffer and fill it. This is the same in our MS-DOS demo, is the same on Amiga. The API is just exposing the buffer, and you just have to fill it with the refresh. This refresh function is hiding all the complexities of Amiga chipset. It's doing the chunky to planar conversion, and with some specifics, but maybe I will talk about it later. But yeah, this is basically the inner loop of our demo. Okay, about the music. You might think that modules are the, core or essence of Amiga Demoscene, but you have to think differently. Finding musicians who would do a module for you is pretty hard. They have the fancy VST plugins, all the fancy tools. So if you want great music, you have to look towards, let's call them PC musicians. They will provide you with the streamed music. And it's not that bad as you might think. It's not really true to the spirit, but it's much better from the quality point of view. You have the mastering and all the proper stereo separation. You can seek easily inside the music. You can rewind your demo without all the issues that modules have with rewinding the music. Also, the overhead is really low. I think we are using ADPCM for the compression. That's 60-bit at 28 kilohertz frequency. So if you check it on YouTube, it's really sounding decently, or if you were at any party that we were releasing, okay, except one, where it was sounding like shit. But in general, it's really great. And the overhead is like 5% for the general demo. And if you have some memory resources to spare, you can even pre-compute it at the startup. So yeah, that's what our framework contains. And you might think that's not much, but that's really a lot if you are approaching a demo. You basically have all the tools that are required to put some visuals on the screen. But the talk is not done, and we will continue. So that would be too easy. You have just the tools for the developer to work with Amiga hardware, to abstract the hardware for him. But we want speed, we want rapid development, we want to test things fast. And that's where additional tools come in. So, give me a second. Okay, there's no demo yet. Demo will be later. Yeah. So we will need UI for the variables tweaking, external applications that help the artist mainly to experiment with the parameters you built into your effects. Other than that, you need some UI. Okay, you don't need, but it's nice to have some UI for color correction, because when you are remapping graphics, some color information is going to be lost. So you need to boost some contrast or decrease some contrast to build common tint for whole demo. So I will show some UI to help the artist to handle this, because he's the best guy to do it. You don't even try to do it if you are a developer. You are not the best guy to handle this stuff. Okay, I have a demo now to show, but I think I will group it later so we can have everything in a single batch. And UI for synchronization. That's the part we introduced latest to our toolchain. Because previously, all our demos were kind of hard-coded when it comes to synchronization. You had a block of if-elses in the main loop, which were launching a separate effect at specific time. Also, each effect was hard-coded, how the parameters were changing through time. It was all hard-coded. I thought it was great until I tried external tools, and some of you might know it. It's the Rocket by Kushma. So I will also show it a bit later. I don't want to break it, but it's the greatest introduction to our toolchain. And I think I can show now most of the tools that we are using. I think I will start with our latest demo, how it works with the external synchronization tool. I don't know. Okay, I have a problem because you can't see it. Okay, I will just close the... Okay. Oh, God. Okay. Just bear with me. Wow, the delay is insane. It's going to be fun to watch. Okay, so that's our Amiga demo with UI made on Amiga, actually. And I will show you how the tool that's used for the synchronization works together with the demo. So here you have the Rocket editor. And here you have the demo. So everything is controlled from the external application. If you run it, you see the demo running. If you stop it, the demo is stopping. You can move forward, move backwards. You can go to the specific part of the demo. You can tweak parameters. As you can see, the variables that I was talking about earlier are exposed separate tracks in the editor. So everything you change here, even the progression of time, even if time is going forward, then you can make it go backwards or shift it or anything. And that's the part that's make it easiest, as you can see. And maybe you can't hear it, but also the music. You can hear the music. See, you can rewind, you can modify stuff, and don't even have to exit this editor, and you constantly have the view of your demo. So that's the main part we introduced it, and yeah, that was the most important thing. We managed to synchronize whole demo in like half an hour before the deadline because we were really running short of time. So yeah, that's the great tool. If you are not using it, yeah, start to. And I will show another example of the palette tweaking interface. That's one of our earlier demos. This one doesn't have Rocket integration, but it's sharing the same interface. It has a bit different management of the timeline, more simple, but also allows for rewinding. Okay, and I will stop it. And I will show you how the artist has the control over the palette. Each effect has the palette assigned. This one is called like this. And this blank area is some other component which I'm not going to be showing, but yeah, it's something else. But the graphician has the possibility to adjust the hues of the effect, some basic tonal shifts, brightness in certain areas. I can't. Yeah, he can change the brightness, he can change color saturation, and he can save it for the effect. Original setup is still preserved, but he can modify it on the fly. And it works especially great for monochrome palettes, but it also works good if you have some palette based on the image or things like that, especially adjusting some tints and saturations. Let me close it. Okay, so that's for the Amiga specific stuff. And Okay, let's continue with the slides. Where's my pointer? Ah. Okay. So we have the basic tools to make a demo. How do you make a demo not having an Amiga? You want to work on PCs, right? So all the stuff you are coding, you are always keeping a fallback, even if you are optimizing in assembly, you always have to keep the fallback in C. Always try to keep it in sync with the version, even optimized one in assembly. So you can run it on a proper PC hardware. You have to take care about the endians. I don't know if you are familiar with endianness of data, but PC and Amiga differ in that area, and you have to handle this stuff when loading and saving data. Because you want, for example, if your effect is caching something, for example, at exit or at precalc, you don't want that data to be wasted. You want to reuse it on Amiga. So you have, when saving that, you still want to save it properly. Okay. And the last point, I was talking that we are not really using Amiga hardware, but there are some features of Amiga hardware that are nice to use. For example, planar graphics, when you are writing just to the separate plane, some selected planes and not touching the others. But that's not a problem. You can emulate it in your PC version of the framework, so you still see the proper image that's going to be generated on Amiga. So if it's easy to emulate, just emulate it. So when you are approaching an effect, you are writing something on PC, it looks great, you are satisfied with it, it's awesome, you're going to win the world. You send it to your slave or friend, however you call it, he tests it, and it runs at 1 FPS. Yeah, that's usually how it's going to look like if you are new to Amiga programming, because you don't have the ratios, how fast the effect has to run on PC to work properly on Amiga. So you have to learn the ratios, and it's going to vary between effects. Different types of code differ in speed on Amiga and PC. So it's not like you have 1:10 ratio, how fast the effect is going to run. Don't depend on that, but with time you're going to learn. And the last point is that 12, 13 FPS. That might sound low, but it actually works for most demos. If you are not trying to be one-frame demo or something like that. So if you are entering Amiga demo making, just target that and just aim for some flyby, I don't know, some effects that don't require fast pace. But yeah, effect runs slow, and do you really trash it, or you are trying to save it? So the usual stuff. You are software developers, so okay, some of you, and you know the general idea about optimization. Just don't be lazy. Don't do calculations that don't have to be done. Obvious stuff. This is especially important when you are aiming for the low-end hardware. So yeah, replace trigonometric functions, pre-calculate stuff, which I'm going to talk about a bit later, how you do it, because it's not really pre-calculate everything and it's going to be fine. So So when pre-calculating stuff, you would think that just create a huge lookup and everything is going to be nice. Because it's not going to be nice. You can't create multi-megabytes caches for everything because you're going to run out of memory. But also, the smaller the lookup, the more friendly you are going to be to the cache. This is probably the most important high-low level optimization you can do on Amiga, because the CPU is reasonably fast, but the memory is terribly slow, especially cache misses on Amiga. So you have to build your lookups to be cache-friendly. And I will show one example. Okay, not show, but talk about some example. This is the common case you are doing on Amiga demos when working with palettes. You have some color, and you need multiple shades of it. And that's basically you build a shade lookup table when you combine the color index and the shade index. For 8 bits of color and 8 bits of shade, you have 64 kilobytes of lookup, which is way too much to fit into the cache. And if you are randomly walking through that cache, you are in trouble. So the best thing you can do is think how your effect looks, because in most cases, the shading is going to be smooth. It's going to change in low frequency data. So it's going to be good. But some effects have smooth background and noisy shading. This is when it's nice to reverse this lookup, because it's going to be more friendly for the cache. So you are not going to be missing so much when accessing memory. This is really effect dependent, but you have to think about it. Also, another idea is, how can I reduce the cache? You can reduce number of shades. Okay, that's great, but it introduces bending. And we want our effects to look reasonably nice. So why not adding some noise? Noise first adds some filmic look, you know, because noisy graphics are kind of more interesting. But it also helps you to reduce amount of data you have to keep in memory. But you might think that noise is expensive, so I don't want to do it in my inner loops. But it's not really expensive. You can do noise in 2 CPU instructions, fairly decent noise. So you can, for example, use 2 bits of noise to reduce amount of lookups by 4. And it really helps you both visually, because sometimes you just don't have the shades in the palette, and it also helps with performance. But it looks crap on YouTube. Yeah, you might think about SIMD. This is the concept that one instruction is operating on multiple values. You can also do it on CPUs that don't have this built-in into the CPU itself. You can, for example, put multiple smaller values in one register. So with some tricks, I think I have a slide for this. Okay, I don't have a slide for this. But with some tricks, you can just split the values in one register and, for example, generate some blending operations, some masking, It basically works best with full screen passes. When you have to, for example, add a glow to your effect, it works really great with multiple values stored in the same register. Okay, I have something in my notes, but I didn't put it in the slide, sorry. And the frame coherence, I don't know if it's the right term to call it, but when you look at the effect, it mostly looks similar looking at those separate frames. one frame to another. Not much stuff is changing, so why not use this fact to optimize your stuff? For example, if you have a lot of particles on the screen and you have to calculate their motion, they are moving in general quite smoothly with some predictable kind of motion if you look at several frames. So why not calculate the motion for example, every third particle each frame? So you can reduce the cost by to one third over the time, and just use values calculated over the previous frames for the particles you are not calculating in this current one. With noise and particles moving through some noise field, it works really great, and it allows you to bump amount of particles or reduce the cost of calculation. And the third one, we are running at low resolution. Especially if video team is not applying any smoothing to the screen, you have to take care about the quality. You don't want too sharp pixels, you want at least some kind of anti-aliasing if possible. Yeah, I know it's hard, but you have to think about it. But can we go lower without sacrificing this quality? Actually, we can for a lot of stuff. When you are calculating effects which are low frequency in general, like glows, some post-processing effects, some displacement maps, which are not noisy, they are usually smooth data. You don't have to calculate them at the full resolution, and upsampling them without duplicating pixels, but smoothly upsampling them is really cheap in the inner loops. Sorry, this microphone is not really catching everything. Yeah, so for some stuff, if you are bidding the effect as multi-layer effect, just calculate different passes at lower resolution and upsample when applying to the actual effect. And we did that, we are doing that almost for all effects we are doing. Works great. Okay, so let's say that you did your effect, you are reaching almost acceptable frame rates, like 9 FPS. in most, okay, I don't know how to call it. In some cases, you can just ship it. 9 FPS should be enough for everyone. And sometimes it works, but in most cases, yeah, it doesn't. So this is the part where this is probably the hardest part for people without Amiga background. You have to start low. And this is also the part where emulators break. Because the funny fact is, when you optimize the code for the real thing, it's often going to run slower under emulation. So you really need to either optimize blindly or do really often run trips with your friend with real hardware. So how, okay, give me a second. Okay, I will talk about the compiler that I'm using. This is not something that you can apply to every compiler. But these are going to be the practices that I'm doing before even touching assembly. So, first of all, check the disassembly. Now, this is the part that you are going to need assembly knowledge on Amiga, unfortunately. At least the minimal part, and some knowledge how to optimize for it, just to judge how good the job the compiler did. You have to know how to judge it, because otherwise it doesn't make any sense. So, first policy, unroll. But don't unroll too much. Usually unrolling twice, because 060 has two pipelines, and it helps compiler to split the job. It usually gives good performance benefits to unroll twice. But don't just copy the code one below the another. That's not the point. The point is to interleave the instructions. You have to help the compiler with the interleaving, because then it can help to occupy both pipelines better. Register allocation, that's another part. You want to keep your data in registers. That's the common knowledge. You don't want the compiler to spill registers to the stack and back. First, it introduces unnecessary instructions, and in general, it's slower. Compilers are crap with register allocation in general. So you have to look at your code and see what the compiler did with it. For example, compiler can do weird stuff like allocating a register for the loop counter, which is really wasteful, and you don't want to do that because it's just used once per iteration and it's occupying one register. How do you force compiler to not occupy a register for the loop counter? Basically, just declare it as volatile, so it's going to be accessed via memory storage all the time. And it's also freeing the register for other stuff. Also, as Amiga has 8 general data registers and 8 address registers, compilers are pretty stupid by not using data registers when they can do it. So you can just declare some normal variables as pointers and operate on that. That's going to also release some pressure from other parts of the code. In general, in Amiga compilers, parameters are passed by registers. But that's not really almost ever important. The important part is the inner loops. Only you don't have to care about the prologues and epilogues of the procedure. You have to just call about the inner loops. If the prologue or epilogue is important, you just inline it. Because when it starts to matter, you want to inline it. Okay, so we helped the compiler. It's doing pretty decent job at allocating the registers, but we can't help it more. It's still looking pretty crap, and we see some bottlenecks in the code because you can now judge it. Yeah, so we have to go to the assembly, unfortunately. So grab the PDF, which is mentioned here, and straight jump to the chapter 10. Chapter 10 describes how to pipeline your code for O60. This is the chapter that you should read 10, 20, 30, and I'm not joking, times, because this is the most important part when optimizing for O60. It mentions not instruction cycles, because most instructions on O60 are one cycle, with some exceptions, like division, but it mentions how the instructions pair with each other when they can run at theoretical half cycle per instruction. This chapter explains it, how to put instructions between other to utilize free slots in CPU pipelines. You have to read it, and you will read it multiple times really to understand all the intricacies. And you might think that it might be easier to grab some disassembly of actual procedure generated by a C compiler, look at it, and then maybe fix it and reassemble. But usually it is harder than rewriting everything from scratch, because you compilers really generate code that doesn't look nice. And with the amount of code that you are going to be dealing with, like procedures shorter than 100 lines, it's really easier to write everything from scratch than maybe having the output of the compiler as a lookup and then writing everything from scratch is the best approach. Okay. Wow, that was fast. It's 20 minutes only? Okay, my talk is going to be shorter than I thought it would be. So I will talk about some asset management that we are doing in our demos. Because when dealing with palettes, you have to convert your data. You often work with graphicians who are painting in true color formats, like 24 bits, and you have to bring it down to 8-bit. Usually it doesn't work that nice, but then they have to fix it or you go grayscale. Because we never, for example, worked with graphicians who are pixel graphicians. We always worked with graphicians who are doing graphics in Photoshop and other similar tools. So we have to do with the conversion, and they have to suffer seeing the results. That's why you often cover the graphics with the effect, and yeah, they suffer less. Or you just tell them to do some modifications so less color variations are used. But we have a tool that helps with the process of generating the lookups for each effect. Yeah, I will show I think I will show. Yeah, that the tool allows you to build the common palette from multiple images. It allows for remapping, for example, when you have textures for a scene and you have to generate the common palette from all the textures. It can do that. It can also generate the shades for it, because if you have some shading in the effect, it's going to do it for you. It can do downsampling, some color correction, and dithering, which usually you don't want to have, but yeah. So that's the syntax of the script for the tool. It can take multiple parameters, multiple files, generate the palette. And we have this for all the effects. So when the graphics change, we just rerun the script and everything is regenerated without much effort. So even Graphician can do it without my cooperation. And also this palette adjustment tool that I was showing previously, which allows for final tweaking, because when you are building the common palette for the effect, it often reduces, it often reduces contrast, and sometimes if you are using dithering, you don't want too much contrast. You can lower the contrast, for example, for some effects. It is destroying, okay. It is destroying the look, but sometimes you can afford to destroy the graphics for the fact that you are making an effect. Sometimes you want to move forward with a demo, even when suffering from eternal punishment from the graphician. So it really is the goal more than, you know. And yeah, it was really short. I thought it would be longer. But if you have some questions, maybe based on what I told, yeah, I would like to hear them. Sorry? Via network. The benefit of running a demo, because we are not banging the hardware. We have a demo running without killing the system. So you have full network stack running, and Okay, that's the thing I was not talking about. The benefit of our framework is that we are not killing the system. You have all the output visible in the console. Your demo is basically running in a window. You have all the console output. You can dump all the timing data to the files. For example, when your friend is running the demo, it can dump all the timing data for you. It's really important to log as much data as possible. So he can send it to you. I will be back to your question in a second. It's really important not killing the system. So you can have much more diagnostic tools running in the background. Because if you kill the system, you don't have I/O, you don't have visibility of the console output, you can't run proper Amiga debugger at the same time. And it's really handy having some Amiga knowledge to run Amiga debuggers, because even if you debug your demo on PC as pure C code, it's going to break on Amiga. And it's really great to being able to run proper Amiga debugger together with your demo. And back to GNU Rocket. You also have proper TCP stack running. So you can have demo even not running on emulation. You can have demo running on a real thing, and with some hardware, you can connect it to the PC and do the synchronization on the PC. So, yeah. And it's also hidden from you. You don't have to care about it, because even in official branch of GNU Rocket, it's now called Rocket, there's a code for Amiga TCP handling, so you don't have to care about it. You just plug it in and go with it. Anyone else? Sorry? No. Yeah, and if you are going to use GNU Rocket, tell your musician to not use variable BPM. Yeah, because it has really handy utility stuff when you tell the editor the BPM of your music, so you can skip in constant steps. If you don't have constant BPM, you can't do it, and you have to insert your tracker commands kind of blindly, and you can miss something. With low FPS, it doesn't matter much, because you are going to miss the synchronization points anyway. But if you are doing fast-paced effects, you probably want to stick with constant BPM, and then enter this BPM into that editor and work with that. I asked the same question to Kushma, and yeah, the answer was simply no. Okay, so we are in about half an hour. Okay, and I think if you don't have any more questions, I'm done.